Okay, so a limit is the value that a function will go when it goes to a certain point. And what I mean by that is that when the certain value, for example, in this limit, I'm going to go from x to 4. And in this case, we know basically for whatever f of x is, we want to know what value you're going to get when x approaches 4 from both sides. Now, when it says x goes to 4, then that implies that both the left side and the right side will both meet at the same point at 4. If they just want to know what the limit is from the left side, then it would go x4 with a negative next to it. And if they just want to know from the right side, then there would be a positive next to it. So, for this limit right here to exist at x going to 4, then that must mean that the limit as x goes to 4 from the right of f of x must also equal the limit from x going to 4 from the left. If all this is true, then this limit from x going to 4 exists. Otherwise, that limit does not exist. So, for example, different graphs where the limit would exist would obviously just be a normal graph. If this was 4, then approaching, and let's say this is 6, then the limit from the right of this line would equal 6. From the right, it would also equal 6, and for this reason, the limit is simply 6. Now, because we're just talking about where the limit is and not what the actual value is, there could actually be a hole or a point of discontinuity at this point, and it would still be a fine limit because from the left and the right, they're still approaching the same spot at 6. Now, a function is continuous if the left and the right side of the limit equal each other, if the actual value exists, so in this case it would not be continuous, but if the actual value exists right here, and that the limit from the left and right, or just the limit itself, equals that. So in this case, it would be continuous if the limit as x approaches 4 of f of x not only exists, but it actually equals f of 4. Now the definition of this, instead of 4, it'll say c, as x approaches c, f of c, but as long as it fits all of these conditions, it's continuous. So therefore, this line is continuous because the left and the right both meet at 6. And f of 4 equals 6. Because they're the same thing, this is continuous. Other examples of continuous lines would, let me go into saying what would not be continuous. If there is an asymptote, right here, let's say this is x equals 4, well, the limit from the left is infinity. That equals infinity, which also does equal the limit from the right. But this does not equal f of 4 because f of 4 does not exist, because it's infinity. And I know you're thinking that if this is infinity and this is infinity, this is infinity, then this should exist, but it doesn't, because this does not exist. However, I think a better example would be if it was something like this, because then it definitely could not exist, because this would be infinity, this would be negative infinity, and this simply does not exist.